Hello everyone, my name is Pranjal Pandey, and in this video we are going to understand about one of the most important data structure in DSA, which is tree data structure, binary tree data structure. So over this video we are going to understand how the data is stored in tree in form of tree, and how nodes are connected, and how address is passed between these nodes. When we call a tree, we actually mean that any data structure which is in form, let me have a pen, in form of a tree where there is branches, there is root which is a starting point, where is the end is called as leaf. So why I'm telling this right now as I'm starting this video, because in this tree data structure, why this called a tree is the main reason that the terms in this data structure are segregated and explained in a term where most of the things we can understand by relating with a tree. So let's start this video, and we are going to know how tree is different from array and linked list. Now, okay, so let's start by the first understanding that what is array and what is linked list. So array and linked list both are the data structure which are having their own sequential way of storing a data in a data structure, while a tree is in a, here I have given the definition. A tree is a nonlinear hierarchical data structure, unlike array or linked list, which means array and linked list both stores the data in a sequential manner, which means a single form of data or single entity of data is stored after the another data, which means thus we can imagine array as or linked list as a train continuously channel of train blocks, where each block is connected with another block in a manner that that any of these entity of data can be found by moving in any order from end to start or start to end to get the actual data and what we are seeking for. While in the tree, we know that here it is an example of a tree data structure. Here I have given E. So, okay, we have a example A, B, C, D, E, F. Okay, so this data is going to be stored in form of tree. Over here, we have given a tree where A have two these arrows. What this called? We called it as a edge, and this is connected with these nodes. We call these nodes, and the first element, the very first element in this tree, we called as root, which is a top node called as root, whereas the nodes which are below or moving downwards, those nodes are called as child, whereas the single node which is sharing both nodes is called as parent. Okay, so node with children over here is called as parent, and node below a parent is called as child. Okay, so and here it is another thing which is leaf. What is leaf? Leaf, let's what I've taught you earlier, leaf in a tree, which is the last entity if we move from the starting point of a plant. Starting means where it starts or starting to grow. Okay, from the root it goes till the leaf, going through the branches. Okay, so over here the last entity is leaf. Similarly, over here in this tree data structure, D is called as leaf cause it is not mentioning any other address. Okay, so I think till now it is clear. to us what is tree and how a structure of tree actually is. Okay, moving forward, let's read some of this theory. Okay, let's take a real life example, file system. We have a file system in our computers where we store. Just like if we have to store a movies in a folder, then if we have to separate a Bollywood movies, Hollywood movies, and Telugu, Tamil, whatever we want to see. So we can separate in the folder of movie. We make a single folder movie, then we separate it into Hollywood and Bollywood. And we can choose whatever we want by moving throughout this hierarchy and moving to our required data. Okay, similarly, this tree structure is, you can imagine it and try to understand. DOM in HTML, when we see the websites, those are created using the code, but it actually shows in a form of DOM of HTML. Okay, organization hierarchy, like in a school we have principal, then after principal we have our headmasters, teachers, and after that we have our students or other teachers, the categories of teacher, the senior teacher, the junior teacher, like a professor or assistant professor, similarly like that. So okay, let's see why tree is considered a non-linear data structure. What I mean by non-linear, as we have discussed earlier, in an array by this example of train, it is linear. That data is moving in a single uh, path. If we want to traverse throughout the data, we have to move in a single path, that one data is after another. There's no hierarchical order. That it means, what I want to say, that if a single object is stored in 100th address, then next will be in 200, and then third will be in 300, but there will not be any data entity which is 500, and after that there is a data which is stored in a 400. So what I want to say is, this data is stored in a sequential manner, whereas when we see the tree, it's not like that. So data in tree is not stored sequentially, that is, not in a linear order. Instead, it is organized across multiple levels, forming a hierarchical data structure. Because of this arrangement, a tree is classified as non-linear data structure. Like in array and in linked list, data is in linear form. Over here, this is an array. For example, 0, 1, 2, 3, 4, 5. And over here we have another example, 0, 1, 2, 3, 1, 2. Okay, if we want to continue. So this is linked list, this is array. Every data is after another, but in a linear manner. But when we talk about tree, after having one, we have to create nodes. Nodes, what I want to say is that this one will share the data which belongs to this address of this value, where the 2 is actually um, defined or placed or stored actually. Okay, if here is 1, then it will be 2, and the other level will be shared as 3. So over here we have levels in a tree. Level 1 of what I want to say, that one is at level 0, then it will be 2 and 3 will be at level 1. Then if we continue this tree structure, then we will go with 4, and over here 5, then 6, then 7, then 8 or 9, whatever we want to go. So over here, the 5, 6, 7 is on same level, 8, 9 on same level. And these 5, 4, 6, 7, not 7, 6, 8, 9, these are leaf nodes. Whereas 1 is root node and 2 is a parent of 4 and 5. Similarly, okay, so I guess till this we are clear with our theory part, what we want to cover. Okay, so while the tree data structure is important, although we have array, linked list, and stack queue, which we can use to store data. Then why we need actually this kind of data structure where we have to define the hierarchy and address are stored in a level like 0, 1. Just I explain what. So over here, let's see. Tree are useful for strong data that naturally forms hierarchy. Okay, whenever we want to store any kind of data which needs hierarchy, it's the requirement. We cannot give classification of principal and student until in a structure of defining the value or the position of every member till we know the value of them, the hierarchy in the professional manner, that how they belong and what the kind of position they hold. Okay, so according to this, we need tree to define this kind of data structure. Similarly, file system on computer data. Computers are structured as tree with folder containing subfolder and files. If you have done a somewhere development, web development or app development, we have to define different folders in a backend folder for doing the various activities. Like if we wanna uh, do some routing, we have to define route folder, and we if we want to give some kind of model, we have to give a model folder. So similarly, like this, this is a tree data structure where it comes in a play. Okay, similarly, DOM, document object model of HTML page, is a tree. The HTML tag, eh, the root dot head and body are its children. Okay, these tags can have their own child nodes forming a hierarchical structure. What I've taught that in a website, when we see, it is not just components or some pictures. These are the DOM of HTML, which we can see, which is coded in a backend with different languages, which is shown in a form of data object model in a for a user as a web page. Tree help in efficient data organization and retrieval for hierarchical relationship. What this means, efficient data organization, that what I've just let's take another example. If we see in our judiciary, or if we see in our army or any kind of that services, like in police or any other services, we have different posts which are necessary, because every post has their own rights and their duty. The duty of a subedar or a constable cannot completed by a IPS. Similarly, an IPS cannot do the role of inspector or any other role. So everyone has their role, and according to their hierarchy, the kind of importance or kind of job they have, the hierarchy of the job or the importance of the job, this hierarchy is formed, and the data is being organized in that manner. Okay, moving ahead, we have this very nice diagram over here. Okay, what I wanted to taught you guys earlier was this. If we are storing that we saw earlier, one over here, two, three. Okay, so how we know that this thing, that line we know? Okay, how this one knows about the two? That two is its child. Okay, and similarly for 3, that how one knows that 3 is its child. So if we see in this diagram, we know. So okay, this is the basic structure how a tree works. Okay, did you guys saw about the doubling list? And if you saw, that will be very great. So over here, this is our data. Okay, with this data, we have two node pointers which are pointing toward this address. Okay, what is this 100? 100 is the address where this data 2 is saved. Okay. And what is this 300? Similarly, what I've taught, this is the address of where the 4 is saved. So when we moving from 1 to 2, we know where to go to find the data 2 from 1 so that it can become its left node. Similarly, when we go for 200, we know we are going towards 3. It's another child. And when we go from 3 to 5, we know we are going toward its child. By taking those node addresses, that 200 of this 3 and 500 is for this 5. Okay, so this makes clear that how actually it practically this can be possible. It's not like magic that one is going to hold the two values together and this will go on for 2 and 3. It's not like that. The address are saved so that the next value can be found, and this hierarchy structure, the hierarchical structure is can be formed. Okay, so in this video till now we understand how a data is stored and what is the importance, how it is different from array and linked list, and what do you mean by hierarchical data structure. Okay, so try to read this thing, and this will be a first part, and later on we will go with some DSA problems in this, and we will also cover the topic where we can define the node, how to define a node, and how to save the list tree values like in this form A, B, C, D, where nodes with left and right child. So this will be in our next video. So till now, thanks you.